Okay, good evening. So week 8, Tuesday, we are going to continue our series on compound loading analysis. Now, this is the most uh, integrated topic in this lecture because we're going to apply what we have learned over the past 6 weeks to solve one problem. Okay. Before we go on, I'm going to talk about term test 2. Term test 2 will be held on 5th of July, and I believe it's a Tuesday, and the time will be from 7 to 9:30 in the evening, and is in person. The location is in Bird Science Building, 120, and you have 2 questions for 2.5 hours. Okay, so I will tell you where the test will be up to maybe next week. Okay, so let's quickly recap. So we were solving this problem on Tuesday of last week. So just to quickly summarize what we have done. So I'm going to write a quick level of summary. Okay, so a summary how to analyze compound loading, just to help you to recap. So the first thing we were to do is to locate or define the transformation. So what do I mean by that? So we draw our transformations for this question, the direction of the transformation is given. So this is our x, this is our y, and this is our z. Okay. Then the next thing that we have to identify is the location of the element. Okay. We have to define the location of the. So for this case, in this question, the location on the elements are given. Okay. When you become a professional engineer, it is not necessarily given. Okay, so you have to identify the positions. Remember, I spell with an S, where maximum stress will occur. Okay, so it's not just one place. Okay, you have to. Sometimes you're not sure. It's possible to have more than one element position. It's fine. It is okay. Okay, so you locate the position of the element. For over here, we have element H and element K. And then the next thing that you do is you locate the position, the neutral axis, location relative to the elements. Okay. So now for this case, we know that element H and K are the elements, and then now we are going to identify our neutral axis. This is just an estimation, a guess. Okay, it can be off, it's fine, but at least you know where is the position of the neutral axis. Okay. Right. So this is a guess position of the neutral axis relative to the element. Okay. Then once you reach it to this stage, all you need to do now. Sorry, I'm trying to see messages. Okay. Okay. So once we have done this. The fourth thing is to analyze the structure in 2D plane, right? In 2D plane. So remember, last week we did XY plane, right? So we sketch it in XY plane, and then you view it at YZ plane, and then you view it in XZ plane. Okay. Then the fifth thing to remember when you analyze, while analyzing the 2D plane, ignore the dots and crosses. Okay. So what we mean by that, I'll quickly review what we have done last week. So last week, right, we look at a problem like this. Okay, so let's focus on this diagram that you can see on your screen now. So this we are analyzing on our XY plane. And you can see crosses, right? You can see crosses. I'm going to circle in blue now. You can see crosses and you can see dot. So we will ignore, okay, or we will not analyze the crosses or the dots. We will only analyze the arrows. Okay, that's what we mean. And then we have, so from here, right, while analyzing, okay, we can also determine the normal and shearing stress induced by the load. So there are generally two groups of formula that we're going to use, and you guys know this already. So for normal stress, okay, for normal stresses, so let's say we use in the x direction, we're going to have px over a, right, plus by my over iyy multiplied by z minus by mz over izz multiplied by y. Like what I always mentioned before, do not worry about the positive and negative. You will analyze the structure later on. Remember, I told you guys the head of the moment vector is positive. The tail end of the moment vector is negative. Okay, so as you can see in this formula, this is induced due to axial load or axial force. And over here, bending moment on the y-axis, and then over here, bending moment in the z-axis. Okay, so the normal stress are usually the easiest one. Okay, the easiest, the not really difficult, but a bit more analysis is required for shearing stress. Okay, so shear stresses, you have shear, so this can be equal to Tx. Okay, before, yeah, I will do this, Tx C over J plus by Vy over IZZ QZ over T plus by VZ over IYY QY over T. And we know this is due to the torque. And over here, these are due to the shearing force in the Y and Z axis. Okay. Right. So the next thing to consider, okay, not the next thing that is more confusing, okay, where a lot of engineers make a mistake is this. Okay, we know that moment. Okay, we are aware that moment is equal to force multiplied by perpendicular distance. Okay. In fact, what I'm writing now, it can be a very good summary sheet for you to study, okay, for analyzing compound loading situation. Okay, so let's look at moment. Okay, moment is equal to force multiplied by perpendicular distance. So we are going to focus on this. Okay, so the confusing thing is this. Okay, I'm going to get this image across again. So if we're going to view this, I'm going to view this in our XY component first. Okay, XY plane, sorry. I'm going to view this in our XY plane. So this is X, Y, this is rotation from Z. Okay, so I'm going to again sketch this out. Okay, so this is a sketch. So I will draw the position, sketch the position of the neutral axis, right? And then put in the elements that we're interested. So this is our element H, and this is our element K. Okay, so the thing I want to focus on is this force over here. And this is 150 pounds. Okay, so for this case, the 150 pounds, so we know that the force is 150 pounds, and the distance from here to here, this is 10 inches. Okay, so the moment about the z-axis acting on element H and element K, right? So mz is equal to 150, right, multiplied by 10. So this is 1,500 pound each. Okay. So I will show you a different view now. Okay, I'll show you. So this is to the neutral axis. Okay, I'm going to show you a different view now, and I'm going to show you in the x z plane. Okay. So now this is our x. This is our z. This is rotation y. Okay. So I'm going to sketch the plan view now. Okay. And I'm just going to focus on one force, just one. Okay. And then we are going to look at the the neutral axis. Right. So then we are going to sketch our element